Welcome to next session on signals and systems. Today we shall focus something further on two-dimensional numbers, the systematic way to deal with it, so that forms the basis for your entire coursework, may it be continuous systems, may it be discrete systems. In general, we consider that the signal is a two-dimensional variable. Mapping of a two-dimensional variable on another independent variable, which is usually time, is taken as a signal. So in general, for entire course, let us consider that a rotating point, or not rotating, the position signal is a hypothetical signal on which entire course can be based. That position of a point in 2D plane which varies, it is a move, or to be more precise, a moving point on the whiteboard is signal, and it moves in x direction, in y direction, or overall in a 2D plane. Then there are methods to describe it appropriately in standard way, standard rotating signal, like that. So we proceed with, I hope that now we need to come out of voltage, current and all these things, or pressure, temperature, etc. In general, a signal means a moving point on whiteboard is signal, and everything is based on that. So we entirely concentrate on a position signal in an hypothetical manner, position signal where the position of a point, we take an example of laser gun, putting a point. Position of the laser tip on whiteboard is a signal. The independent variable is time, dependent variable is position. Position is two-dimensional. So one two-dimensional variable is stated as an ordered pair of two one-dimensional variables. Now the complex number theory is developed, and further complex exponentials, in order to simplify dealing of these two-dimensional signals by various mathematical operations, and therefore, remember, therefore, we take help of complex numbers. So now it is x-axis, it is y-axis. Now this is the position. So what is a position signal? Something which is moving like this. So at given point of time, it is having this value of the position signal cannot be described by using a single real variable. Position of the point cannot, in a 2D plane, cannot be described by using single real variable. It requires two real variables. So PT, the signal, position signal PT is nothing but an ordered pair of PH and V, we can say. PHT, how much it is horizontally away from origin, and PVT, or conventionally X is defined as horizontal and Y is defined as vertical. So now, suppose if the point moves, you can draw perpendiculars to both axes. The perpendicular will have its projection on x-axis and on y-axis, and now if you move this point, its projection points will also move. So PHT or PXT is the movement of horizontal projection of the point PT, and PVT or PYT is nothing but movement of position, movement of vertical projection of the point on y-axis. So position signal PT is an ordered pair, ordered combination of two. Then what these signals are? These are also positions. PT is a position signal. PHT or PXT is also a position signal. PYT or PVT is also a position signal, but the difference is that PXT, I think now H and V we ignore, we accustom ourselves with X and Y. So PXT and PYT are again position signals, but there is a restriction on their movement, that the projections only move on given axis. So by describing a single real variable, again, if we go in minute details, then a real variable with sign and a real variable without sign is also something mattering, but right now we means mass can't be negative, but voltage can be negative. So it's just a small example I am giving. Mass can't be negative, voltage can be negative. So mass and voltage, even though both are scalars, mass and voltage, even though both are scalars, we find that mass can be completely described by a number, whereas when we describe voltage by a number, you should also say whether voltage is positive or negative. When we say positive or negative, then in that case, to be very precise, I hope that if you are quoting it somewhere to some of your friends, then quote with caution, because you may not be able to quote it to the fullest extent. Keep it with yourselves otherwise. So if I say mass is a one-dimensional variable, in that case, mass is one-dimensional variable. Voltage is also one-dimensional variable. Are both same? Mass is one-dimensional variable and voltage is one-dimensional signed variable. So it is dimension, I can say 1 plus, because to express voltage, you have to express a number, also its direction. So is voltage a vector? Is voltage a vector? Not in true sense, but not a pure scalar like mass. So it also has got direction, but the directions are only two, and those are indicated by sign. So I hope that you try to understand it. You are still in the second year, so you need to have your strong mathematical background of understanding all these things. So projects, now what will happen? PXT and PYT. PXT will always be on x-axis, PYT will always be on y-axis. Therefore, position of PXT and PYT can be described by a single real variable. And when I say real variable includes a sign. So Px, that is the projections of point, are one-dimensional signals, whereas position of a point is a two-dimensional signal, and a two-dimensional signal is nothing but an ordered pair of two one-dimensional signals. So position P, here is function of time. In general, position is x comma y. So x comma y is a joint two-dimensional variable where it's an ordered pair. Now it's a very interesting question that concept of z. Listen very carefully. Pay very huge attention to each and every word. As regards to education, it is said that Vivekananda has said that education is manifestation of perfection of an individual, which already exists within him. Then what is the role of educator if it is so? Can we give an example that we are having seeds? We sow the seeds, we give fertilizer and water to the, we find that tree gets developed out of the seed. And the role of the person who is maintaining it is to give just fertilizer and water. Then just by what fruits will come to the tree is not in the hands of the person who is upkeeping it. So a completely fixed treatment of water and fertilizers and maybe insecticides, if there are some insects are there, then you may treat them by using pesticides, insecticides or pesticides. But what it will grow, what fruits it will give is completely within the seed. Like that, whether the role of the educator or teacher is restricted to that, in that case, some few fundamentals are to be given and the student will develop something on his own. Then, listen very carefully, if somehow the concept of complex number, concept of imaginary number z is not at all introduced because it is complete wild imagination, means after coming to a conclusion that it is not possible to arrive a negative number by repeating the multiplication process, means that the square root of negative number doesn't exist. So an attempt to call a non-existent entity on horizontal axis, preparing an orthogonal axis and placing it on that axis is a very rich level of imagination. Now suppose if the question is whether that kind of imagination world is not imaginary, or world is imaginary is also a very, what we can say, puzzling question, but let us be realistic. So in real world happenings, something happens, something grows, something contracts, something evaporates, everything is real, we can say. In that case, there is no scope for some imaginary thing. My question now is, if the variable z is not taught, if the students are not exposed to the theme of variable z by any means, if they are protected by all means of the exposure to z, in that case, whether they will be able to understand every happening without knowing z, or whether few of them would be able to independently develop the concept of z, so as to simplify the things. It remains to be seen. So let us say whether complex number, concept of imaginary number is a necessary condition to understand everything, and the answer is no. Answer is no. You can work on all two-dimensional variables by using ordered pair. You can carry out all the processes also by some method. Only thing is that it takes much time to solve. That was scenario few centuries back. Now everything is computerized. Then computer will do that, and there is no computer may use Z for some kind of algorithm, may use that properties. But for us, for me as such, there is no need of Z. Means an RC circuit and a sinusoidal input, to find the answer, there is no need for me to treat capacitive reactance as 1 upon J omega C. Without knowing Z, by a very effective differential equation manipulation, I can find the answer, because final answer doesn't include Z at all. So the richness as regards to easy representation of things in 2D and manipulating it mathematically for different operations, that is made simple by the concept of the variable Z. So in that aspect, variable Z is used by us. So in fact, actually this complex number theme itself is a very rich theme, and we may require 4 or 5 sessions to explain in detail, but that much time we don't have right now. So in short, so we restrict our discussion to use of complex numbers, or first use of Z, complex number is coming something later, use of Z to represent two-dimensional variables. Two-dimensional variable is ordered pair. So instead of, listen, I am explaining it in very simple form. Instead of explain a point, listen very carefully, a point P x comma y, where x is its x coordinate, y is its y coordinate, P is a position variable. P is a position variable where it is having 2 dimensions. So position variable C is expressed by an ordered pair. To indicate the order of the pair, it is expressed in alternative way by x, or we use Z also alright, but we use, let us say, A comma B, position A comma B, where A is its x position, x projection, B is y projection, or x coordinate, y coordinate. So the position variable, a 2-dimensional variable A comma B, order, if I have got P A comma B and another point Q B comma A, these are not same, these are different. Because order is important. This is expressed alternatively by A plus ZB, and it is said to be a single number. A single number where the separate is just like what you can say. I am giving a very simple example. Very simple example. Suppose if that 2 students reside in 2 rooms, there is a common light meter, there is a dispute. It's a so simple example I am just deliberately giving. There is a common flat, 2 students reside in 2 rooms, common meter is there, but there is a dispute who uses how much electricity. Then 2 submeters are put. With respect to MSAB, a single meter. There are 2 separate meters, so separation is there, but the example is not to be taken 1 as to 1 because there is not direct addition. Simply, A plus ZB is a 2-dimensional number, and it is expressed as a complex number C. A complex number C has got 2 parts. A position variable has got two coordinates, like that it has got two parts, a plus jb. The sequence is also part without j, part with j, and when we perform various operations to measure, raising we will discuss later, addition and multiplication. When we perform two operations of addition and multiplication, number one is that j square is to be taken as -1. Except this we always keep, means a plus jb and plus p plus jq is equal to a plus p plus j into bracket b plus q. So parts with j are not to be clubbed with parts without j. So just this j square equal to -1, just this j square equal to -1 makes the things very simple in carrying out the process of multiplication, addition, all these processes. So this you always keep it in mind, that a complex number consists, and then just as a convention, there is nothing like that imaginary part is inferior to real part. So it has got two parts. This is called as real part, this is called as imaginary part. Imaginary is not at all anything inferior. Real part and imaginary part. With this, it is possible to effectively represent and utilize two-dimensional variables. To effectively represent and utilize two-dimensional variables. We now move further, and in that, now there is quite an interesting thing I will explain briefly. J square equal to -1 is very well explained. So you just try to go through the contents. This is not given so effective in the book. You need to think a lot on that. So I am just giving some information, even though we are not so much comfortable in time where we are running out of time, because many things are to be taught. So this is 1, this is j, this is -1, and so this is -1 and this is -j. Just a circle I have drawn, I will explain the meaning later. We will slowly move. Now listen carefully. I want some answer from you. Only thing is that since it is a recorded version, I can't listen to you. So whenever I give some task, I will tell that you can pause, find the answer, and then either verify the answer, or if you are unable to find, then listen the answer. Okay. This is origin. Now, I will explain in short the complex exponentials to you. Prior to that, you have heard the number e. You have heard the number e. Now, how number e is a real number? Listen very carefully. I am trying my level best to explain in detail as well as in short time. E is a real number. How number e is arrived as? E is limit of something. E is limit of something. That a very simple example is given. Suppose that you put some amount in the bank. You put some amount in the bank, and let us say that it's a hypothetical only. After the interest rate, listen very carefully, I am explaining it in very simple language. I hope everybody will understand. What is its significance and what is the uniqueness, all these things we will elaborate in next session, so that you are, once the J, E are well understood, we are well equipped for the entire course. So interest rate is 100% per year. Interest rate is 100% per year. So if you put 1 rupee today, then after 1 year you will be getting 2 rupees. I hope it is quite simple. If you put 1 rupee in the bank today, after 1 year you will get 2 rupees. 1 rupee, after 1 year it becomes 2 rupees. So interest rate is 100% per annum. दर साल, दर शेकडा, जुनी मराठीत होती 100%, 100% per year or per annum. Okay. Then you go to the bank. Banker tells you that yes, we are having a very good scheme, 100% per annum. Then there are two persons. One, obviously, for an investor, whatever more he gets, he always wants that. So two investors go to bank. And one asks, no, so can I get more interest rate? Obviously, it is not in the hand of the manager. He says, no, I cannot. It is not possible. And then there is another smart guy, smart investor. What he says, okay sir, no problem, absolutely no problem. Your interest rate of 100% per annum is quite fine for me. Only thing is that you pay at 100% per annum on half yearly basis. You pay, listen very carefully, this being very important theme, I am using very less speed. Then he says that it's all right sir, I don't have any problem, but you pay the interest at 100% per annum, half yearly. 100% per annum, half yearly. Then manager thinks that, okay, I think, is he demanding any hike in rate? No. Then he says, oh yes, no problem. Then what will happen? When the interest is half yearly paid, when the interest was yearly paid, 1 rupee, in 1 year, interest was 1, it became 2 rupees. Now what will happen? Interest is to be paid half yearly at 100% per annum, means 50% per 6 months, right? So there was 1 rupee. After 6 months, 0.5 were added, so it became 1.5. And then again in 6 months, 0.75 will get added, it will become 2.25. It will become 2.25. Is it right? Okay. Then this concept is known by another person who is quite greedy. Then he says, okay, why you said it that only 6 monthly paid? Can't it be paid quarterly? Means 4 times a year. So in that case what will happen? If it is paid 4 times a year, 1 will be there. After 1 quarter at 100% per annum. So 25% per quarter. So it became 1.25 after 3 months. After further 3 months, how much it will become? 1.25 into 1.25. 1.25 into 1.25. And it would be how much? The interest would be 3 and 1. So 3125. To be very precise, it would be 1.5625. After that, how much it would be? After that, how much it would be? It is after 3 months. After further 3 months. 3 months. After further 3 months. After further 3 months. 1.5625. In that, approximately 39 will be added. So when 39 gets added, it becomes approximately, I am calculating it, 1.95. And after 3 months, it would be, in that, further 49 will be added, 2.44. So, if 1 rupee is invested, 100% per annum interest rate is to be paid. If interest is to be paid annually, 1 rupee becomes 2 rupees. If interest is to be paid quarterly, 1 rupee becomes 2.25 rupees at the end of the year. If interest to be paid annually, 1 becomes 2. Half yearly, 1 becomes 2.25. Quarterly becomes 2.44. Then you will say monthly, it will become 2.6 or so. Then you are very much greedy. Then why monthly? Weekly, daily, hourly, per minute, every minute. And what is every instant? What is instant? Instant is an infinitesimally small quantity. So the interest rate is to be computed. Interest rate is to be computed at the rate of 100 rupees per annum. Something will come per instant. Per day it will be 100 by 365. Per day, 100% per annum. So it would be 100% per annum, 100 to 100. So if I say rate R, so 1 plus some variable, and that variable, when it was only once, it was 1 plus 1 raised to 1. Then 1 plus 1 raised to 1 is 2. Then 1 plus 0.5 raised to 1 upon 0.5 is 2.25. Then 1 plus 0.25 raised to 1 upon, that is 1 plus 1 raised to 1 is 2. 1 plus 0.5 raised to 2 is 2.25. 1 plus 0.25 raised to 1 upon, that is raised to 4 is 2.44. So like that I can say 1 plus 0.1 raised to 10. So if I give it 10 times in a year, 1/10th of a year, then if I say 100th of a year, 1000th of a year, so in general I can say is as 1 plus x raised to 1 upon x, and x tends to 0. The amount will not, only because you are taking interest instantly, you will not become, with 1 rupee in 1 year, by taking interest instantly you can't cross Bill Gates. The amount maximum is limit is there, that is one limit as x tends to 0. Even if you take interest instantly, 1 plus x raised to 1 over x, and that number is around 2.7179, so and so, that is called a real irrational number E. A real 2.7178, I have approximated something like this. So a real number is E, it is not rational, it cannot be expressed in P by Q form where P and Q are integers, but it exists. So, and it's a fixed number, the amount will not go merely because you calculate in interest instantly and go on adding into the capital. The amount will not rise by leaps and bounds. There is a limit of compounding of interest, and that limit is E. So this is the number E. E has got a very peculiar things, that E raised to x is unique. E raised to x is a unique variable where its derivative f dash x equal to fx. A variable where its derivative is same as variable. So where slope is equal to actual number, slope equals actual number, this way will e raised to x. It's a very special. We will elaborate it as need comes, but this is number E. So E and Z are combined and they give us outstanding results. They give us outstanding results. So let us try to think now. Everything is hypothetical. Raising a number by imaginary number is very interesting thing. So let us have, say, somewhere here it will be E, and we can have a general number. Okay. Again, I need to restrict somewhere and not go into all details because of the want of time. Let us restrict somewhere. So 1 I am having. So if I go for, if I raise 1 by a number x, what will happen? What is 1 raised to x? What is 1 raised to x? It's a very interesting theme. As long as x is finite, as long as x is finite, 1 raised to x is 1. The number doesn't increase. Raising a real number is changing the value of that number. But if the number which you are raising is 1, 1 doesn't get raised. Means raising 1 is some process, it can't be raised. So 1 raised to x is 1, where x is finite. We don't go into, if x is infinite, 1 raised to infinity is indeterminate. 1 raised to infinity is indeterminate. On some other occasion we will discuss that. Let us be very clear, let us say 2. This number is 2 and this number is E. Now you raise 2 raised to x, or first we say 2 raised to an integer, 2 raised to 2. So what is 2 raised to 2? 2 raised, in fact, raising is successive multiplication, but it can be learned independently also. 2 raised to 2. So what is 2 raised to 2 take 1 and multiply it by 2 number of times. So it is 4. What is 2 raised to 3? Take 1, multiply by 2 by 2, it is 8. Now what is 2 raised to? Listen very carefully, it's a very fundamental that is required for other. If we don't discuss that, then just by simple formula and all these things where everything is fishy, I don't believe in that. So if I say in between these two, 2 raised to 2.5, what it is? Now it is 2 raised to 2.5 when it is there, then you express it as 2 raised to 5 by 2. You express it as 2 raised to half raised to 5. So 2 raised to half is root 2. And then you multiply root 2, you take 1, root 2, root 2, root 2, root 2 and root 2. So it is 4 root 2. It is 4 root 2. But now if so 4 root 2 is 1 point something 4 into 4, it is something like 5.65 or so approximately. So it is obviously 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 2.5 has to be in between 4 and 8. Then 2 raised to 2.1, or in general, if I say 2 raised to x where x is between 2 and 3, 2 raised to x will be between 4 and 8, but if x is in the p upon q form, then you will find out qth root of 2 and multiply 1 by that number p times. But if it is not in p by q form, if it is not in p by q form, in that case, so listen very carefully, what exactly is meaning of raising a number, how you will convince yourself. If number x is in p by q form, then you can do it. If number x is not in p by q form, then you will take two numbers, one which is less than x, other which is more than x, which are in p by q form. Then you will be finding out qth root, raising it p times for number which is just less than x, just more than x. Those 2 points will locate and your 2 raised to x will be in between that. So concept of for raising, finding out qth root and raising it by p times where both q and p are integer, that is required. But a completely new theme, I think. I don't know to what extent you would be able to thinking deeply on it. Is it necessary to know real integers? Can there be a non-integer thinking? World happening in the world, physical parameters in the world, they grow, they contract and they change. There is nothing like integer. There is nothing like integer. Integer is for our counting. Can there be a branch of mathematics where integers don't exist? Raising a real number, raising one real number by another real number, what that is, how you will visualize that? I will leave it up, the question open to you. So now next. So this is just a very rich material for you to think. So when the number is more than 1, and when you raise it, when the number is more than 1, and when you raise it by a positive number, the number grows. So it is 2. Then it is 2, number 2 is 2 raised to 1. So when you raise it by something more than 1, it will grow. When you raise it by something less than 1, it will contract. when you raise it by 0, you come here. So it is 2 raised to 0. When you raise it by negative number, it will further contract. So not raising 2 means 2 raised to 0, you are at 1. You can raise it on this side, you go here. So 2 raised to 0. This will be half is 2 raised to minus 1. 2 raised to 1. This is 2 raised to 2. So by any means, you go on these sides. Now my question is, listen, it's a very fundamental question. What will happen if when sometime somebody might have developed complex numbers or concept of Z? Then when the concept of Z was developed, there may be very much enthusiasm. Yes, Z square is equal to minus 1 and all that thing. Then when the thing started, somebody, a very extraordinarily curious student in your class might have asked the question, what will be this 2 raised to Z? What will be 2 raised to Z? Once Z is introduced, what is Z raised to 2 you know? Z raised to 2 is minus 1. What is 2 raised to Z? And then in that logic one will say, what would be Z raised to Z? Those who are very much studious might know Z raised to Z in their mathematics. So it is a real number actually. So, but how to tackle this problem? This we keep for further discussion. This we know. So we focus on this. 2 raised to Z. 2 raised to Z. What I said, when we were discussing only raising by a real number, 2 raised to 0 was 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to minus 1 is half, 2 raised to minus 2 is 1/4, and so forth. Now what will be 2 raised to Z? Whether the index Z is having any real part? No. Index Z does not have any real part. So you are not raising 2 by a real number. Or I can say real part is 0. I can say real part is 0. So now one thing which is very, very amply clear here, we should go by the theory of negation. 2 raised to 0 is this, 2 raised to 1 is this. So each and every number from 1 to 2 will be corresponding to 2 raised to that x which would be between 0 to 1. So this entire number line from 1 to 2 is occupied for some x such that this x is lying between 0 to 1. So each number here is occupied for some x. Each number from this to 4 is occupied by x1 to 2. Each number from this to this is occupied by 1 to minus 1. Between this to this is occupied by minus 1 to minus 2. So each number from 0 onwards, each number from 0 to infinity is occupied by some x. So for every number I can represent by 2 raised to x, and x is between 1 to 2 here, 0 to 1 here, 0 to minus 1 here. So 2 raised to z will not find any place on this line. 2 raised to z will, because it is 2 raised to something, 1 1.2, 1.3 such that. So 2 raised to 0 will not find any place. So when I am raising for index other than 0, I move on this side or I move on this side. If index is 0, I am here. If index is 0, I am here. So raising by j, it does not include any real component. J is not having any real part. So what would be there? Raising by, just like in previous case, when square root of -1 was, means how I reach to -1 by repeating the process of multiplying to 1. I can't multiply because multiply is scaling, so I have no answer, but I now extend scaling to rotation. Here also raising to by a real number is scaling. Raising to by a real number is scaling. Then what we can have is whether raising a number by imaginary number, listen very carefully, it is, I am trying to develop it within you. Raising a number which is not 1, if it is 1 it is different. So I have taken an example of 2. Raising 2 by imaginary number, will it be something other than scaling? Will it be something other than scaling? And when it is other than, means 2 raised to 0 is here, 2 raised to 1 is this, 2 raised to half is this, 2 raised to 0, 2 raised to 1, 2 raised to half. When from 0, when you move on positive side, you scale. On negative side, you scale down. So now means you scale up for positive index, you scale down for negative index, you don't scale for 0 index. What will you do for index which is neither negative nor positive nor 0 but imaginary? So how we visualize, it is complete imagination. How do we visualize raising a real number by an imaginary number? And the answer is, instead of scaling, it is rotation. So if 2 raised to 0 is this, 2 raised to 1 is this, 2 raised to -1 is this, 2 raised to j is somewhere here, 2 raised to -j is somewhere here. So raising by j is, when you don't raise 2 raised to 0, anything raised to 0 is 1. When you raise